Hello, and welcome to our lesson on understanding decimals and their position on the number line. Today, we will explore how decimals fit into our existing number system, enhancing our ability to represent and work with numbers in a precise manner. In this lesson, we'll build on our current understanding of number line positioning by incorporating decimals. Our main focus today will be on understanding how to place decimals accurately on a number line and how this representation aids in various mathematical applications. We'll begin by revisiting the number line, recognizing positions of integers and fractions to establish context. We'll delve into the fundamentals of decimals, examining how they relate to place value. Then, we'll practice positioning decimals on the number line, ensuring you can visualize their exact locations. We'll apply this knowledge to practical examples, showcasing how understanding decimal placement can solve real-world problems. In our previous lessons, we've established a strong foundation by discussing the number line and understanding how numbers are arranged in an ordered, linear fashion. We have also learnt about fractions, recognizing parts of a whole, and how these are positioned between integers. We have also covered place value and learnt about the value of digits depending on their position in a number. With this solid foundation, we can now explore how decimals fit into the number line seamlessly. This understanding is crucial for tasks such as comparing numbers, performing precise calculations, and interpreting data. For instance, imagine you are working on a budget and need to accurately allocate £234.56 rather than a rough £235 or £230. Knowing how to position and interpret decimals ensures precise financial planning. Let's dive right in and enrich our number sense by mastering the placement of decimals on the number line. Before diving into decimals, let's briefly recall what's meant by fractions. A fraction represents a part of a whole. For example, if you have a pizza sliced into 4 equal pieces and you eat one slice, you have eaten 1/4, 1/4 of the pizza. Fractions help us understand how parts relate to the whole. Now, let's revisit the number line. The number line is a visual representation where numbers are placed in order at equal intervals. It typically looks like this. Between these integers, whole numbers lie fractions fitting between the segments. For instance, 1/2 lies between 0 and 1. Just as fractions represent parts of a whole, decimals do the same but using a decimal point. Decimals provide another way to express fractions. For example, 1/2 can be written as 0.5 in decimal form. The decimal point is a key feature that separates the whole number part from the fractional part in decimal numbers. For instance, in the number 3.14, is the whole part and 0.14 is the fractional part. Let's break down a 3-digit decimal number, say 0.627. Each digit in this number has a specific place value. 6 is in the tenths place, 2 is in the hundredths place, 7 is in the thousandths place. The name tells us how many parts the whole is divided into. A tenth, 0.1, is 1 part out of 10. A hundredth, 0.01, is 1 part out of 100. A thousandth, 0.001, is 1 part out of 1000. This concept can be extended to any decimal number, no matter how many digits it has. Each digit's place value diminishes by a factor of 10 as you move to the right of the decimal point. For whole numbers like 627, we understand it as 6 hundredths, 600. 2 tens, 20. 7 ones, 7. We don't typically include places like tenths or hundredths for whole numbers because they would just be zeros and wouldn't change the number's value. So 627 is already precisely represented. To help visualize this, let's use a decimal place value chart. Notice that place values are symmetrical around the unit, ones, and decimal point. Just as tens are 10 times a unit, 1/10ths are 1/10 of a unit. Understanding this symmetry helps in comprehending how decimals fit into the broader number system. Next, we place these decimals on the number line. Consider 0.5, 0.25, and 0.75. On a number line between 0 and 1, 0.5 is exactly halfway between 0 and 1. 0.25 lies halfway between 0 and 0.5. 0.75 lies halfway between 0.5 and 1. By positioning decimals in this manner, you can see their relative size and better understand how they relate to each other and whole numbers. Let's practice positioning some decimals on your number line to solidify this concept. Let's place 1.3 on the number line. This decimal falls between 1 and 2. Since 0.3 is 3/10ths, we need to divide the segment between 1 and 2 into 10 equal parts. 1.3 lies 3 parts from 1. Now let's place 2.75. This number is between 2 and 3. Since 0.75 is 3/4, we divide the segment between 2 and 3 into 4 equal parts. 2.75 is positioned at the third quarter. For a negative decimal, let's place minus 0.4. This falls between 0 and minus 1. Since 0.4 is 4/10ths, the segment between 0 and minus 1 is divided into 10 equal parts. Minus 0.4 is positioned 4 parts from 0 towards minus 1. These examples illustrate how to accurately place decimals on the number line. This skill is crucial for comparing and performing precise calculations in various mathematical contexts. In today's lesson, we expanded our understanding of the number line by incorporating decimals and their precise placement. We began by revisiting fractions and their positions between integers to establish context. We then transitioned to decimals, highlighting how they represent parts of a whole, similarly to fractions, but using a decimal point. We delved into the significance of the decimal point, separating the whole number part from the fractional part, and explored place values in decimals, such as tenths, hundredths, and thousandths. To aid visualization, we used a decimal place value chart and noted the symmetry around the decimal point, which reinforced how each digit's place value diminishes by a factor of 10 as you move to the right. This helped us relate decimals to whole numbers and understand the broader number system. Finally, we practiced positioning decimals on the number line, illustrating their relative sizes and their relationship to whole numbers. By mastering this concept, we can enhance our number sense, compare numbers accurately, and apply this knowledge to practical scenarios, such as precise financial planning. This fundamental skill will aid in solving real-world problems and performing accurate calculations. Watch the rest of the GCSE Maths course at Sophos Education.